Okay, the squeeze theorem says the following. If f of x is less than or equal to g of x and g of x is less than or equal to h of x, when x is near a, and if the limit as we approach a of f equals the limit as we approach a for h, both of these limits are L, then the limit as we approach a for g has to also be L. Well, think about why that's true. H is always bigger than G. So this green graph represents H. This dark one in the middle is G. And this one is always greater than, right here it happens to be equal to. So this is actually, right here is where our A is. Likewise, G is the smaller of the functions. That's the red one. And it's always less than or equal to, F is always less than or equal to G, yeah? So it just makes sense. If this is always greater than or equal to G, and this one is always less than or equal to G, well, and this both are near L, approach L when we approach A, G has to approach L the same thing. It just has to, right? So now let's do an example, concrete example using this theorem. Okay, so it's a fact that the sine of pi over x is always between -1 and 1, right? So using that fact, let's verify that this limit is 0. All right, well, first of all, we know that this fact here, we're given that. Now let's multiply all three parts of this compound inequality by the square root of x squared plus x. Because if that's equal, if we multiply all three parts by some quantity, it's still going to be a true compound inequality. So if I multiply the left, well, -1 times this square root is just minus the square root of x squared plus x. When I multiply this by the square root, we get the square root times sine of pi over x. And 1 times the square root is just that square root. Well, now if we take the limit of the two ends, so the limit as x approaches 0 of the left side, and the limit as x approaches 0 of the right side, I'm just using this theorem now, the limit of the left side equals the limit of the right side. Well, the limit as we approach 0, it's just the square root of 0 squared plus 0, which is the square root of 0, which is 0. -0 is the same as 0. This limit, we get the square root of 0 squared plus 0, which is the square root of 0. The square root of 0 is 0. Well, the squeeze theorem tells us that if the left and the right functions, as we approach, in this case, 0, if they're both equal to the same number, which they are, then the middle quantity has to also, that limit as we approach 0 also has to equal this number, which happens to be 0. So by the squeeze theorem, this limit has to be true, as I just explained, according to the squeeze theorem.